Good morning to all. In this video, we will discuss how the 8-bit division program is written in assembly language program for 8085 microprocessor. Basically, we should understand the program by understanding the architecture of 8085 microprocessor. In an 8085 microprocessor, we have got a 6 general purpose registers, that is B, C, D, E, H, L. In addition to the general purpose registers, we have got accumulator A, which we cannot use it for our own purpose because we have to perform all the arithmetic and logical operation using accumulator. So whenever accumulator is free, we can use it, otherwise we have to keep it for arithmetic and logical operation. Since 8085 microprocessor does not have a divider or multiplier hardware, so we have to do this division or multiplication with the help of subtraction and addition respectively. So in this program, let us say how an 8-bit numbers are divided. So normally we load the numbers, two numbers are there, one is the dividend and the another number is the divisor. So for example, 25 is divided by 5. We will take that and we will see that the numbers are stored in the memory location 4200 and 4201. So we are initializing the memory pointer here, and then we are moving the 0 for C register so that the quotient is initialized as 0. Quotient is initialized as 0, and then the first number, that is the dividend, is copied to register D, and then we are incrementing the H register pair, HL register pair, and which means we are incrementing the memory pointer to take the next data. Now the memory pointer becomes 4201, and then the next value is copied to accumulator, and again we are copying the second number, that is a divisor, into the B register also. Now we are comparing the divisor with 0. Now divisor is in accumulator, that is compared with 0. So if it is 0, then what we have to do is we can simply know the result. No, number cannot be divided by 0, it is infinity. So we just simply go to the end of the program and then simply load the output as EE. It's like an infinity or error or whatever it is we are calling. Or in case the divisor is not equal to 0, in this case we have got 5. So the comparison means the 0 flag will not be setting, so it will go to the next instruction. So move A comma D, which means the dividend is 25, that is copied to the accumulator. Now you can see the content of accumulator is equal to 5. So I have just explaining the content of the register step by step. So let us say we just remove this. So now what we have done is we have copied content of accumulator into D register. Now it is 25. So quotient is available in register C, and remainder we have not assigned any register for that, and we will see that how the remainder is getting. So now what we do is we are subtracting the accumulator from the B, which means accumulator is having a 25, that is a dividend, and B is having the divisor. So 25 minus 5. So first time I think I write it as a iteration 1. So 25 minus 5 becomes 20, and then the quotient is, no, for one time I am subtracting, so I am putting quotient as 1. So remainder we don't know now. Okay. So now what we do, what will happen? Jump carry. So there is no carry because 25 minus 5 was happening. So carry is not set. So jump carry only, it will go to the loop. Otherwise it comes here. Now the C register is incremented, which is quotient is incremented now. Now only the quotient is incremented 1. Earlier it was 0. Now it becomes 1. Okay. Now what will happen next? It will jump to loop 3. This is an unconditional jump. Whenever the instructions are here, executing here, it will directly go to the loop 3. So loop 3, what happened? Subtracting b. So once again, this is a second iteration. In second iteration, what we do is we are subtracting 20 minus 5. 20 minus 5 is 1c. If you want, you can verify with the calculator. So where is our calculator? So we have a calculator here. Just close this. Yes. So we just say 20. Okay. We just clear. We go to hexadecimal, and 20 minus 5 is 1b. Okay. So 20 minus 5 is 1b. Okay. So since we have subtracted second time, we are increasing the quotient as 2. So that is what is available here. After subtraction, there is no carry generated. We have incremented the C register by one more time, that is 2. So now again it will go here, and again it is subtraction. That is the third iteration. Third time we are repeating this. So 1b minus 5. So we will go to the calculator. This is 1b minus 5. We get 16. So we just type 16 here, and then so after subtraction there is no carry generated. Now increment the C register. Now it becomes 3. So now it is again going back to the jump. So once again, this is the iteration 4. So 16 minus 5, we know it is 11. Now it is incrementing the C register. It is 4. So now it is again repeating for the 5th time. So 11 minus 5. So what is 11 minus 5? It is 16 minus 5 is 11. That is minus 5 is C. So we get C here, and this is incremented to the 5th time. So now this is the 6th iteration. So now it is C minus 5. What is C minus 5? C minus 5, you can verify, it is 7. So it is 7 here. Again it is incremented to 6. Again this is a next iteration. So it will 7 minus 5 is equal to 2. It is incremented once again. Now during the 8th iteration, this is very important, you have to listen properly. So during the 8th iteration, 2 minus 5. So 2 minus 5 becomes FD. See, this is minus 5. 2 minus 5 becomes FD. So we can remove this. Okay, this is okay, FD. So this is the byte. FD only is available in the calculator. Okay. So what is the content of accumulator now? Now it is FD. So now you can see carry is being generated because FD is a negative number. Now carry should have been generated because 2 is the small number and 5 is the big number. So definitely carry is generated. Now what will happen? Jump carry to loop 2. Now it will come to the loop 2. Then we are adding B. So what is B? B is 5. So this 5 we are adding. So what will happen now? FD plus 5 becomes 2 because we have separated 5 from 2. We have got FD. So when we are adding, when we say add B, FD becomes 2. So now we are not increasing because the increment is happening here. Now we are not incrementing the C register. So now what will happen now? We are just adding B and incrementing the HL register pair, that is a memory pointer, and the memory pointer is incremented, that is 4201 is there. See, now it is 4201. It will go to 4202. So in 4202, what are we going to do? We are copying the content of, you can see, 4202, that becomes a M register. So M register, what do we do? Copy the content of C, that is a quotient is 7, 7 is copied to M register, that means 4202 is taking the value of 7. Now we are incrementing the H once again and we are moving the content of accumulator to M register. So 4203 takes the value of accumulator, that is nothing but 2. So the remainder is the content of the last value of the accumulator, that is called as the remainder. So we have repeatedly subtracted the divisor from the dividend, and finally the last time when we are subtracting, we are getting the negative number. Therefore we are adding that negative number to get the remainder. Okay, so how do we check whether the remainder is correct? Once you are executing the program in the microprocessor kit or in a simulator, you wanted to know how the number is, how to find out the remainder. That means 25 divided by 5, we are getting only 7. We are not getting the remainder. So what you have to do is, you have to multiply this quotient and this divisor. So what it is? 7 into 5. So what we are getting is, we are getting 23. So to get a remainder, you just say 25 minus what we have got is 23. So this is the remainder. So this is how you have to check the remainder in the calculator. That is, you multiply the quotient with the divisor. You just multiply the quotient with the divisor. That is, a quotient is 7. Divisor is 5. 5 times 7, you will be getting 23 in hexadecimal. And 25 minus 23 becomes 22. That is the remainder. Okay, so this is the division program for 8-bit numbers. So in the next video, I will explain the division of 16-bit numbers. Thanks for watching, and whatever doubts you have, you can ask me in the comment section. I will answer for all the doubts. Thanks for watching. Keep learning with me.